Hi everyone, in this video we're going to go over some examples of how to evaluate inverse trig functions. So our first example is sine inverse of root 3 over 2. So what am I really asking here? I'm asking what angle theta has sine of theta equal to root 3 over 2. So that's the question. So let's think about this. Sine is opposite over hypotenuse. So one way that you could think about the answer to this question is think about a triangle where maybe theta is here. It's a right triangle. The opposite is root 3 and the hypotenuse is 2. So you might remember that this is one of our special triangles, and so we could complete it. That side would be a half, but it's sort of irrelevant. So what is this angle if opposite it is root 3 over 2 and the hypotenuse is 2? Which special triangle is this? Well, it is our 30, 60, 90 triangle, and the side opposite of theta is, or the side opposite of root 3 is the larger of the two, so this is pi over 3, or 30 degrees. But as we know, sine is periodic, and from what we know about reference angles, sine is positive in the first quadrant, and sine is positive in the second quadrant. So theoretically, we could also have that 2 pi over 3 is a solution as well, because sine of 2 pi over 3 is also root 3 over 2. But it doesn't make sense, because sine inverse, we want that to be a function. We should only have one answer. So what is the correct answer? Well, we need to go back to our definition of sine, of inverse sine. And we said that the range of inverse sine is between negative pi over 2 and pi over 2. So the answer is the angle which falls between negative pi over 2 and pi over 2, which rules out 2 pi over 3. So just pi over 3 is our answer. So let's try another one. Oh, and I'll just clarify this. This is because the range of sine inverse is negative pi over 2 to pi over 2. Okay, so let's try another. Let's do tan inverse of negative 1. So here I'm asking what angle theta has tan of theta equal to negative 1. Well, remember that tangent is negative in the second quadrant and the fourth quadrant. So our angle should fall within one of these, but we know that the range of tangent inverse, the range of tan inverse is, let's go back to our definition from last video, if I can find it. Just a moment, I almost have it. Okay. So the range of the inverse tangent is negative pi over 2 to pi over 2, so that means that our answer should be in this quadrant. But we can use a reference angle. We can ask ourselves what has tan equal to 1, what angle has tan equal to 1, and then just shift that answer into the fourth quadrant using that idea of reference angles. So when is tan equal to 1? Well, that means that the opposite and the adjacent are both the same, which makes this isosceles, which makes theta equal to pi over 4. So if theta is pi over 4, that means tangent of theta is 1, but we want tangent of theta to be negative 1, so we better shift into one of the quadrants where it's negative. We shift into the fourth quadrant because the range of tangent is negative pi over 2 to pi over 2. So all of our possible answers are just in 1 and 4, which means that theta should be, what should it be? Well, we can call it negative pi over 4. because we moved in this direction. Okay, moving on. Cos inverse of root 2 over 2. So cosine is positive in quadrants 1 and quadrants 4, but the range of cosine, of inverse cosine, as we said last time, is between 0 and pi. So while we might end up with two answers, one in quadrant 1 and one in quadrant 4, because our answer is supposed to be between 0 and pi, we choose the answer that's in quadrant 1. So that we can just solve using our usual reference triangle. This is adjacent over hypotenuse. So if this is theta, the adjacent side is root 2, and the hypotenuse is 2. So which special triangle is this? This is the one where theta is pi over 4. Again, it's the isosceles right triangle. In the last example on this page, I ask you to find tan inverse of negative 8.45. Well, that's like asking what angle has tangent equal to negative 8.45. That's a very difficult question because it can't be solved using our reference angles. So what do we need to do? Handy dandy calculator. So if you look at your calculator, there are 3 words written in blue above sine, cosine, and tangent respectively. They say sine inverse, cos inverse, and tan inverse. So first I make sure that my calculator is in radian mode by clicking on mode and making sure that radian is highlighted rather than degree. And now I want to plug in tan inverse of negative 8.45. So to get to this blue, I first press the blue button. So I press second and then tan, and now I have tan inverse. Now I put in negative. Remember, anytime you want to put a negative number, you have to use this one in the parentheses rather than the minus. So negative 8.45 and hit enter. And I find that this is approximately negative 1.453. So we can always use our calculator to solve these inverse trig equations as well. Finally, I have 2 more fun examples for you. These are some of my favorite types of problems involving inverse trig. So let's have a look. I have the composition of tangent and cosine inverse. So let's break this down for a second. Cos inverse of 2 over 3, what this asks for is what is theta if cos theta equals 2 over 3. And then whatever that theta is, I want to know what is tan of that theta. So let's first answer the blue question. If cosine of theta equals 2 over 3, let's draw a picture where that's the case. So this is theta, cosine is adjacent over hypotenuse. So I have 2 over 3. Then I want to know what is tangent of this theta. Tangent is going to be the opposite over the adjacent. So what I need to know is what is the opposite side. So my first step is to draw a triangle and label theta. My second step is going to be to complete the triangle to solve. So how do I complete this triangle? It's a right triangle, so I can use Pythagorean theorem. And I have 2 squared plus, let's say that's x squared equals the hypotenuse squared. So solving this, x squared equals 3 squared, which is 9, minus 2 squared, which is 4. So x squared equals 5, and x equals square root of 5. So finally, to solve this, I say, well, tan of theta is the opposite over the adjacent. So it's root 5 over 2. and that's my final answer. Now I'll do a similar thing with this next example. So I call this theta, and then I want to find cosine of theta. I'm going to first draw a reference triangle. Now this one's a little bit trickier because it has a minus sign, which means that theta is in quadrant 2. So we'll just have to keep that in mind, but if we know that, we can use a reference angle, so we'll just draw our triangle as we normally would. So here's theta, opposite over adjacent, and if we're clever, to complete this triangle, we know this is the 3, 4, 5 triangle, so this side has to be 4. Now, whatever this theta is, it's actually, so here's our original theta. This is the theta from the diagram, so let's call this one theta with a twiddle. Theta twiddle is the reference angle in quadrant 2, but cosine is positive in quadrant 2. So I can sort of ignore this fact because if I do cosine of this theta or cosine of this theta twiddle, I would get the same thing because it's positive in both of these two quadrants. So I just have to find cosine of theta in this triangle, and that's the adjacent over the hypotenuse. So cosine of theta equals 4 over 5, which means my final answer is 4 over 5. So again, 2 steps. 1, draw a reference triangle. Remember what quadrant you're in so that when you plug into the next one, you could possibly change the sign if you need to. But then complete the triangle and solve. So I think that these are really fun because you get to draw triangles, you get to use Pythagorean theorem. It's just it's putting together a lot of the skills that you already have. So let me know if you have any questions, and good luck with the web work.